5.6 pumps, 5.6.1 pumps, pumps, but the scope. The section provides general background information on the pumps used in petroleum facilities and describes common and organizational level maintenance troubleshooting associated with the pumps. Is intended to be used in conjunction with the detailed technical information contained in manuals, operation, instruction, recommendations, guidance. Following subsections should be used from the basis of maintenance plan and tailored to these items as items at your installation. Additional information pertaining to the pumps can be found in the following references: API Standard 610, Central Figo Pumps, the General Refinery Services, MIL P13386 Pumps in Central Figo Multi-Stage, MIL P1769008 Pump, Rotary and Power Driven. Here you see what is known as the strainer components. You get your inlet flange and your outlet flange and your four-way clodge. It's basically, you see the rotation through the filters or through the pumps. It's the strainers. Your outer flange, your four-way plug clock, and your inlet flange. MIL P21214 Pulp Centrifugal Vertical Sump Pump, Military Handbook 201B Petroleum Operations. 562 General Maintenance Requirements for pumps. 5621 Specific Procedures Military Handbook 201B outlines some basic criteria for indicating the needs of performing minor maintenance overhaul of the pump. Minor maintenance such as repacking, packing adjustment, coupling, alignment normally performed. Operators such as pump still installed in the system. These functions accomplished with the care simply improper adjustment for the cause a serve of damage to the pump. The additional general maintenance guidelines is specified from section 5.1. Following the procedure should be observed during maintenance operation field. The pump during operation, noting excessive vibration of the heating radiation of the bearings, packings, the sealing of the indicating necessary maintenance actions, and listening to the unusual flow of the maintenance mechanical noise. After the pump is secured, noted that the excessive physical effort necessary for the hand rotating of the pump, scraping noise of the verified resistance of the rotation inspection, mounting bolts in the foundation of the hardware, cracking. 5.6.2 troubleshooting the common pumps problems. Proper operation maintenance of the pumps essential to the function of the most fuel facilities. In many cases, the pumps do not when most pumps do not operate properly, they may cause B or system condition that is not directly associated with the pump itself. Table 561 summarizes more common pump operating problems and their possible causes. The following paragraphs describes the problem in more detail. No fuel delivered and lack of fuel can be caused by any of the following problems. Empty storage tanks. These are obvious, sometimes overlooked possibilities, especially with small underground tanks. Pumps not primed. The central figure will not occur unless impeller to complete immersed in liquid. For the reason that it is not suitable for applications such as unloading trucks or tanker cars where the liquid level is in storage tank is below. As pump suction is the prime of pump is open. You have your problem and your possible causes. No fuel delivered. Your possible cause is empty storage tank, pump not primed, speed too low, insufficient NPSH, discharge head too high, improper casting broken, working wrong direction of rotation, flow rate of the pressure below, air leaks in suction piping, stuffing box, pump speed reduced, insufficient NPSH, restricted discharge piping, variation of storage tank liquid level, air in piping, air and vapor pockets in suction, motor overloaded, lack of pressure drop and discharge piping, increasing liquid viscosity, specific gravity, internal defects in pumping, low voltage, irregular frequency, excessive noise and vibration, inadequate NPSH, and misaligned, worn, bent shaft or bearing, relief valve, and chattering hydraulic shock. The vent cock of the plug-in is at the top of the volatil. The vent of the cocker plug-in is at the top of the volatil or added liquid in under a positive head and suction connection until fluid of the flows in the vent. Pumping the speed is too low, the motor speeds and too low, the pump has not developed enough pressure to deliver the fuel. Having an electrical check of the motor voltage is not too lower that it all has three phases. The three-phase motors are energized. They check the speed of the tactometer is necessary and compared to the speeds of the nameplate data or the technical manual. Insufficient net positive suction head of the NPSH, which stands for net positive suction head of the next section. NPSH is not net positive pressure working at the pump suction flange to push the liquid into the impropeller rotary piston of the pump, taking into account of the factors of atmospheric pressure pressure if there is an inefficient NPA net positive suction head available. The pump will deliver at less than related capacity possible and not at all. Possible causes are the pump piping is too small, the pump is too far from the storage tank, the suction lift is too high, the fuel vapor and the pressure is too high, the clogged strainer and other restriction exists in the suction pump. Discharge head to the high. If there are reserve restrictions in the discharge system, the discharge points evaluated for the far above the pump may not be able to deliver the fuel. Improper impeller casting broken. Not enough impellers are key to drive shaft that have been caused where they are bound up inside the voltal and broke and around hub. Wrong direction of the rotation. This is rare, but it happened to the new pump and replacing the rewired motor. The direction of rotation of the three-phase power system can be changed in changing the motor lead connection. Most pump casting that have been arrow and shown proper rotation, even though those have been known to be reserved. Flow rating pressure below is normal. Reduced performance pumping can be caused in the following conditions: suction piping leaks, air leaks, and suction piping stuffing the box and suction inside will be reduced. Pump output. Reduced pump speed at low voltage and an open phase in electrical system can cause a lower normal pump speed. Restricted pipe discharge piping. If the discharge pressure is normal above the normal, the flow rate declines its signal through the restriction in the discharge piping that is caused by the dirty filter is partly closed valve and fuel quality monitor that is restriction of the flow. The internal wear of the in the pump, the excessive clearance between the parts of the wearing the rings of the central figural pump, the piston rings of the valve reciprocating the pump, the rotary vanes of the rotary pump will cause a reduction in discharge pressure and the flow rate. The storage tank liquid level, the head of the liquid, the storage tank adds to the pressure developed in the pump in the system. The added the pressure is reduced in this level and the tank drops the head of the liquid. At the tank containing 40 feet of the liquid of 0.82 specific gravity is about 14 psi. At 5 feet of the head of the less than 2 psi, the system pressure is reduced. Accordingly, the air in the piping, the air is introduced to the system from the outside of the source of the positive displacement pump used for the defuel truck, and there will be a reduction of the flow while the slug is in the air pass through. Air and vapor pockets in the suction piping of the air vapor pockets in the suction piping can cause a reduction of complete stoppage of the flow. Figure 561 shows the air vapor pockets can be formed in improper installation of reducers in suction piping should be flat on top and shown in the figure 561, sloping gently in the uniformly upward toward the storage tank. Motor overloaded indicated in the triple circuit breaker and blown fuses higher motor temperature and is caused by one, insufficient pressure drop in the system. Central figural pumps are selected so that the performance curve of the compatibility system curve and the flow reverses the pressure drop. Central figural design of the pump against a fairly high system pressure drops and switch that is much lower pressure drops and the flow rate tends to increase and the horsepower demands tends to increasing accordingly. When the proper demand exceeds the circuit protection rating, the breaker trips and temporarily the solution increases the system pressure of the throttling valve of the discharging pipe, and this will increase the pressure and decrease the flow rate of the motor horsepower, and never attempt to throttle the pump and closing a suction valve. If changing the service is to be permanent and the problem corrected and cutting down the improper diameter, which is the permanent reducing of the flow rate at the proper demand. You see the air pockets in the suction piping. We got an air pocket, the suction concentration reducer, and is not recommended, and it comes out the discharges. These are central figural pumps, and the air pocket formed in the suction eccentric reducer flat side down is in through not recommended to come out the discharge. Eccentric reducer flat side up and no air pocket formed is suction through and out through discharge recommended. You want the eccentric reducer flat side up and no air pocket form when you're going through a suction pump and out through the discharge. Now, liquid more viscosity greater, specifically greater than the design liquid is pumping operation gives this capacity the greater power demand of the viscosity specific gravity product being pumped and decreased. If there is permanent condition, more motor is required. The stuffing box is too tightly backed and slightly loosened in the packing gland. The altering leakage misalignment check alter alignment adjusting as required. Checking casing of the distortion is assigned to excessive stress of the connected piping and low voltage. Irregular frequency AC power system can cause a motor overload and can most commonly happen in the power when the power applied for the small local general planning of the that is not a part of the large power supply grid. Excess noise and vibration. Excess noise and vibration can be caused by the following indication of net power. NPSH. The inadequate NPSH causes liquid to flash into vapor ink bubbles and vapor passing in through the pump and sounding like a gravel marbles are banging around in the pump and the collapse of the vapor bubbles and causing cativation. Worn or bent and misaligned shaft or bearings shattering the relief within the spring setting that is too low. Hydraulic shock and improper design valves into that is close to too fast. Pressure and vacuum gauges analyzing and the troubles described in previous paragraphs, and much of the time trouble can be saved in the high quality pressure vacuum changes or vacuum gauges establish operating condition. Pressure vacuum gauges reading are they too low for a system, probably indicating air leaks in suction piping, worn internal parts for the wearing rings, vanes, gears, and leaking packages. Pressure in the too high for the pump design, usually associated with the low flow rate and no flow indicated in too much resistant discharge system. Low discharge pressure, very high, low, and central figural pump may be indicated by potential motor overload. High vacuum on the suction side, and the no lower flow indicates restriction suction and piping too high, and suction lifted potential vapor. 5623. Routine prevention maintenance. Most of the problems described in the preceding paragraph are caused by conditions outside of the pump itself. Might be to do improper installation, alterated application of the pump. Must be types of of pumps used in fuel systems are ruggedly constructed and with reasonable care for the given any years of trouble-free services. Some items should be indicated in regular maintenance. Problems is flow. Operator inspection when the pump is running, looking, listening, revealing anything unusual such as leaks and hot bearings, vibrating, loosened pump parts and strained noises. Cleanliness, keeping all foreign objects, material away from the pump, and keep wipe away surface clean. Keep the spare parts of the original package and protecting these to keep direct and corrosion. Lubricant if the oil and the lubricated oil cups full. Be sure the oil rings are free and passages of oil of open and clean. Fill grease and cups and pressure type of the fittings of the oil lubricants and type recommended for the manufacturer. Reduction gears found by the rotary pumps may be periodically. Oil changes are recommended for the manufacturer. Check the oil level and quantity below the changes strainers, and if the strainer is equipped for the bottom drain and open and check for the dirt, and remove the clean of the basket in accordance with the operating experience with the schedule and maintenance, complying with the shifting shaft alignment. If there's a vibration running excessive bearings and packing and sealing and wear within the alignment problems, check to see if the pump and motor bolts are tightly disconnect the piping and flanges for the movement and indicate excessive piping strain. Figure 562 illustrates the basic alignments, procedures, pumping shaft and couplings, following the coupling, manufacturing instruction each a particular make and type, stuffing the boxing, packing the rings, the supplies drip slightly for the cooling and lubricant or damage the packing shafting and may result in the air and are over tightened for them only when the pump is running. Here you see the feeler gauge in checking angular alignment and checking parallel alignment on the straight edge. A pump shaft coupling alignment. Mechanical seals do not usually require attention to the properly installed and cooled. If they do not fail, which might be caused by the cooling steam, failure to dirt, defective part, they have to be replaced. Leaking seals may be indicate other problems such as bearing failure, such as misalignment, which causes shaft movement and vibration into the turn and cause seal faces to leak. Coupling cards are occupational safety hazard. Occupational Safety Health Administration (OSHA) requires guards to rotating parts such as the couplings, set screws, keys, gears, and pulleys and belts, ensuring they're securely mounted. 563 gear pumps. Gear pumps are possibly displacement rotary pumps that usually verify the mechanism to trap volume, liquid movements, description, desired direction of gear for the pumps and use of gears, swear and worn gears, lubes, and carry out this function. Figure 563 shows a variety of gear pumps, all types of rotary pumps' ability to handle the high viscosity fluids under the condition of central figural pumps and are not suited. This rotary type exhibits the constant flow characteristic, central figural and positive discharge feature, and reciprocating pumps of the gear pumps themselves, rhyming and heavy constant discharging volume regardless of their fluid. Suction pumps relief of the required discharge pumping and sometimes provided inside the pump to reciprocating fluid of the discharge to the suction of the pump if it is discharge is shut. 5631 description: gear screw and pumps used instead of interlocking close tolerance gears and loops to move the fluid. A driver gear is connected directly to the pump shaft and driver's idler. Each gear is closely fitted into the pumping housing and subject to the wear and if run at the higher speed and use of the pumper fluids and poor lubrication properties. Fluid enters the tooth of space and is carried along with the case into the outlet. The same principle is followed by the rotary screw of the lube, and screw pumps have one driver or one or two more idlers. A gear pump usually has mechanical seals to prevent leakage along the shaft and roller bearings that are cooled and lubricated, and fuel fluid being pumped. In some cases, lubricated in cases separated from the fluid. Mechanical seals may have separated meanings in cooling lubrication. 5632 maintenance. Because of the clearance of the gear pumps, they exhibit the reduced capabilities. The wear will require the overhaul to restore original capacity. Section 5622 covers the troubleshooting followed by the performance leakage problems arise and additional follow-up. Here you see rotary pumps. There are external gear pumps and the 3-lube pump and a single screw pump and a 2-screw pump. These are gear pump varieties of figure 563. Applicable general maintenance and safety requirements refer to the applicable pump and technical manual. 564 diaphragm pumps, and may have positive displacement reciprocating pumps used to the low pressure of a contaminated system. Diagrammic pumps can run dry for the indefinite period without damage. They can pump with the most abrasive fluids and settling tank sludge and little wear on the parts of 564 in the cross section. A typical diagram pump. 5641 description: the diaphragm pump that operates the direction compressed air to the backside of the diaphragm through the air control valve. The fluid is pushed out of the liquid chamber through a check valve, and the diaphragm is pulled into a shaft connected to the pressurized diaphragm. And suction created by the draws fluid of the liquid chamber through the pump into the inlet check valve. When the pressurized diaphragm reaches into its limits to stroke, the air valve shifts and the air supply to the opposite diagram, and the vents air into the side in its limits, and the cycle continues as long as the air supply is maintained. 5642 maintenance. Diaphragm pumps require very little maintenance. Parts in each pump can be replaced if they are found in defective. Problems associated with the diaphragm pump are usually manifest reduction in capacity, indication of check valve and diaphragm pump, or failure of the air valve, and problems caused by pump too short stroke and stop operating. Section 5622 covers troubleshooting should be followed when problems do arise. Always consulting the pump technical manual. Follow all applicable general maintenance and safety requirements. 565 central figure pump. Smooth in a fluid, increasing the velocity of the fluid and transforming the energizer into the pressurizing, reducing velocity. Central figure pumps utilized through forcing a rapidly revolving impeller. The liquid followed and central of the eye of the impeller of the discharges the outer rim of the impeller. The section figure 565 shows the flow path through the typical stage single suction central figure pump. By this type of the liquid reaches the outer rim of the impeller according to the considerable velocity of the liquid. The slowdown traveling through the voltule, where the diameter increases the cross-sectional area of the voltule increases the velocity decreases, causing the pressure to increase. Here you see a diaphragm pump cross section, and it starts with the inlet, going both ways through an upward ball check inlet valve, and through what's known as the diaphragm area of the shaft connection diaphragm air valve, with a fluid side and an air valve paste in through another outlet valve back. There's an air supply pressure given straight into the diaphragm, which has I can't read exactly the side of it, but they have two sides and an air side, and the shaft is connecting down to the airline valve and the fluid side. So the inlet comes in into the ball check area, and then it stays in the diaphragm, and while the air pressure supply valve, and then out through the valve, and out through two outlet valves in the air valve. Here is another picture of a single section central figure pump of the sectional valve. This casing, volatile channel, impeller, drain, suction, sailed shaft, vertical split case, discharge casing, and vent, and suction and rotation. 5651 Description: API standard 610 central figure pumps, general for refinery services, and Navy standard central figure pumps. The following discussion applies for central figure pumps. Informing the standard, the casing of liquid end of the pump within a single suction impeller is made by the end of the plate and can be removed with the implant. Inspection repair of the pump. A pump within a double suction impeller general made of this one half of the casing may be lifted within disturbing disturbing the pump. Since the impeller rotated at a very high speed, they must carefully machine to minimize friction. Friction must be balanced and avoid vibration. Minimize leakage between discharge and suction side of the pump. The casting enclosed radio clearance and maintain between outer hood and impeller and part of the pump in case of the hub rotates. The high rotational speed of the impeller necessarily closing clearance and then rotating surface of the impeller. Hub in case of the point of the subject relative in the rapid wear. The elements are needed for the renewing entire improper pumping case and solely because of the wear in this location. Central figure pump is designed reciprocal wearing pump. One ring improper wearing ring is attached to the hub and improper rotates with the improper matching casing wearing ring is attached to this casing stationary. Wearing rings can be seen in figure 566. Some small pumps with single suction impellers are made of the casing wearing rings only. In this type of pump, the casing wearing ring is fitted into the end of the plate. And in many central figure pumps, the shaft is fitted to the is fitted with replaceable sleeves. Advantage to using sleeves is that it can be replaced economically and entire the shaft. The shaft sleeves are illustrated in 566 and 567. Recirculating lines are installed on some circulating central figure pumps to prevent pumps overheating, becoming vapor impounded, and discharging entirely shut off side. Low piping liquid seals and is also installed in the cool shaft that packing and lubricating in the packing and seal of the joint between the shaft and the packing against the leakage. The lantern ring and the spacer inserted between the rings of the packing of the stuffing backs and sealing the piping leads and liquid from the discharge side of the pump and the annual space between the lantern ring and the web of the ring and perforated so the water can be flow in either direction along with the shaft between the shaft and the packaging. Here you see a stuffing box of the packaging across the sectional view. You see a shaft sleeve, a shaft, a quenching gland, a stuffing box, packaging, and lantern ring, which is this little thing right here. Improper impeller nut and an impeller through a volatile casing suction flange wearing ring. Here you see a stuffing box with a mechanical seal cross section. It is a rotating element, secondary element, a seal area, station seal, a stationary element, a compression unit, impeller coil springs, key away, set screw, stuffing box, gasket, gland, pump shaft, sleeve, and pump shaft. Mechanical seals instead of the packing area used in this variety of central figure. The type of mechanical seal shown in figure 567. And spring pressure keeps the rotating seals the face snug against the stationary seal faces the rotating seal. Then all of the assembly below is affixed to the pumping shaft. The stationary seals as the face is placed in the seal lands the packaging ring and the stationary steel or static seals and the force between the two seals and faces the sleeve and system pressure within the pump again assisted the springs keeping the rotating seal face tight and against the stationary seal face. When the seal wears out, they are simply replaced and a new seal should be not touched on the sealing face because of the body acid greasing causing seal premature pit and fail. Bearing supporting by the weight of the impeller of the shaft, maintaining the position of the impeller both radially and axially. Some centrifugal pumps built into the bearing lubrication system, complete with the lube oil flow with the indicators of other bearings and grease lubricated with the grease cups and vent plugs, constructed with the housing to allow the periodic lubrication of the power and centrifugal pumps may be either steam turbine, most commonly electrical motor, and the rule of the high pressure centrifugal pump as directed drive as this is impeller of the rotates the same RPM of the turbines. However, sometimes low pressure centrifugal pumps have reduction gears installed in the turbine impeller. 5652 maintenance of centrifugal pumps are very independent and proper to maintain packaging adjustment and motor lubrication as usual, and only maintenance on the items that may be required during the operational maintenance. Mechanical seals also require maintenance because the improper install of the true shaft and given along and reliable service regularly trouble in these seals is usable traceable shaft vibration where the improper installation is most important that the seal and faces are protected against the contact of grease and metal and particles. Further in troubleshooting guidelines are found in section 5622, refer to the applicable technical manual, the specific maintenance procedure following the applicable general maintenance and safety requirements. 566 rotary vane pipes. Rotary vane pipes with positive displacement. Rotary pumps the user either swing vane or slide vane to the trap of the segment of the specific volume of the fluid of the movement of the desired location. 5661 description of the rotary vane consists of cylindrical board casing of the suction inlet on one side of the discharge outlet. On the other side, a rotary smaller than the diameter of the other than the cylinder of the bore, and driven is more than an axis off the center of and above the center line of the cylinder, provide minimum clearance at the top of the maximum clearance of the bottom. The rotor carrier, the vanes which move into the out as the rotor returns and seal against the base of the cylinder board, that provide a pumping valve and the vanes to track the fluid of the suction slide and to carry out the discharge slides, where they gradually reduce the volume forces the fluid discharge line. The vanes may swing at the pivots and may slide in the slots and rotary. The vane types are shown in figure 568. 5662 maintenance rotary vane pumps are similar to the gear pumps. They are designed with very close and tolerance for rotating parts. However, the vanes wear to the slide further over the rotary and minimizing the reduction in capacity due to the wear. The requires the rotary vane pipes inspector. They have to determine the number of the operating hours and the ensured continue performance. Periodic perform the infrequent replacement of the vanes should be accepted. For the other problems, refer to the applicable pump technical manuals and following applicable general maintenance troubleshooting and safety requirements. 5671 reciprocating pumps. Pumps are positive replacement and is using a piston moving back and further in cylindric to move the segment of the fluid in the desired direction. The reciprocating pumps with low volume but are sturdy to handle contaminated fluid of the viscosity sludgy materials. Steam powered reciprocating pump is illustrated in 56.9. 56.71 is reciprocating pump is used in piston plungers, cylinders, volume assembles, mechanical control linkage on the suction strokage. The piston smooths causing pressure of the pump cylinders to the top of the suction valve, in which permits the fluid flow to the cylinder discharge stroke. The piston reverses direction towards the cylinder head, causing the pressure to increase the cylinder and suction valve and shut off the scourge. The open cause of the capacity is determined. The valve is displaced. The position of the stroke, frequency of the strokage, discharge pressure determine the viscosity of the fluid being pumped of the pump pack. The pressure created in the discharge piping the pumper and the pump end of the reciprocating may be either in the steam position cylinder agreement of the electrical motor. The other one of the characteristics of the reciprocating pump of the cylinder cylindrical variation discharge of the flow pressure by the using the pumps with more cylinder, verifying the time of each cylinder smoother than discharge with it will produce. Here you see a rotary vane pump, swinging vane pump, and a sliding vane pump. Here is a steam-powered reciprocating power and cutaway view. It goes up the pump cylinder. There's the pump cylinder, the suction valve, the discharge valve. These have releases on it, so it keeps the pressure in the pump of the cylinder. The pilot valve operational stem. The stay rod and the piston valve and auxiliary slide view, and the steam cylinder and the stay rod. So 567.2 maintenance reciprocating pumps are simple in design, operating with the compliance requiring maintenance and attention to the nature of the fluid pump and would indicate the response possibilities of the high abrasive wears of the suction valve, discharge valves, cylinder linings, piston rings, and as well as following in the AL fluid lamp patches of contaminants and steam driving pumps and mechanical controlled assemblies that are prone to wear and require periodic adjustment to ensure that the full stroke of maintaining the piston reciprocating motion or changing in direction can induce vibration and loading piping and supporting and wearing in the valve from near consistent motion, internal disassembly and inspection recommendation, periodic basic and determined operating hours, looking at the worn seals and shaft rings and linkages, erosion and valve seating, pitting on the cylinder walls, excessive free play, and for other guidance following the general maintenance inspection repair recommendations earlier in the chapter in the applicable technical manuals. 5.7 valve.